All right, class. So now we have Euler's method. This is in 2.6. I'm going to show you a couple things here different from the book. But when you're doing these problems, they kind of use the equation that they're giving you, where it's y n plus 1 equals y sub n plus h, and then f of x sub n, y sub n, right? So you guys could use that as well. I'm going to show you a little bit of an easier, in my opinion, easier. Basically what this is, it's very similar to linear approximation. And then as you continue to get closer and closer to the value that you want, you'll get a good approximation for a certain value. Like in this situation, this example I have up here, you start with y of 2 to be 4. They give you a differential. They want you to use that differential and your initial value to approximate 2.5. And you can see here, they give you the steps to take. So h is really like your change of x. All right, so I kind of like to write it this way, where you're looking for your y sub n, which is your initial point, right? Your y value. So I like to have it like f of x, or y of x, we should say. Right, y of x, that's initial given to you, plus your derivative of that value, which is really, this is what that represents. So kind of like, let's say y prime of x sub 0, and then times the change of x, which is really like your h. Okay, so it's a little bit similar to that linear approximation. I'm going to show you a nice easy way, and it kind of keeps everything clear, right? So you start with a xy value. You're going to have your change of x, right? Or you could even call it dx, right? I like to call it change of x. So that tells us what we're doing. For example, if we start with 2, 4, and we want to get to 2.5 with change of x as 0.1, we're going to have to do this a bunch of times, right? 5 times. So we get 2.1, 2.2, 2.3, 2.4, and 2.5. Okay, so it will take a little while. The homework, I only gave you 3 problems just because it's a little tedious in this section. Okay, but what I would do next is think about what's given to you. You have your differential. We could call it dy dx, or y prime, right? So I like to have that dy dx up there. And then I'll have the change of x. So that's where this h times this derivative comes in, dy over dx. So you're multiplying these 2 columns together, okay? And then you get a new point. So it'll be x plus the change of x, comma, and this is really your change of y, y plus change of y. Okay, so it's very simple. So what I'm going to do is now use the differential given, right? So this differential up here and the point. And what we're going to do is plug that in. Okay, so when you plug that in, you're going to need a calculator here. All right, our y is 4, so we have 0.1 times square root of 4, which is 2, and then plus 0.4 times x squared, so times 4, which gives me a 1.8 for my differential. All right, if I multiply those 2 together, right, I multiply these 2, the second and third column together, I'm going to get 0.18. And now you're just adding. So I get the 2.1 comma, right, 4